All right, so in this presentation, we are going to talk about pragmatic event sourcing with functions, and we are going to look at pure functions as well, but we're going to look at different kinds of functions and how you can use functions to structure parts of your application. And this will not be an introductory talk. I assume some basic knowledge about event sourcing and domain events, etc., but I'm sure that you can follow along for the most parts. So the goal of the talk is to explore ways to hopefully make the adoption of event sourcing easier, especially in existing projects. So many times I've read introductions to event sourcing CQRS, and they may seem quite complex and scary, especially if you're a developer that may not be familiar with some of the concepts already. And I believe that this is because event sourcing and CQRS is often used to solve complex and large-scale problems. And while this is a legitimate use of event sourcing and CQRS, I don't think it's limited to these scenarios. So I started thinking of ways, how we could perhaps introduce event sourcing more gradually into an existing code base, or a new code base for that matter, but in a way that resembles how we normally do things. So this is one of the things that we're going to explore in this talk. And another goal is that I really want to present a library that I've created called Occurrent that makes use of some of these ideas in practice. Okay, so here is a way that we can structure the right side of an application when we're not using event sourcing. So imagine that we have an API, and this could be an HTTP or REST API or something. And we get a request to this API. And in this scenario, we say that it's a command. This is the intent, something that we want to do. So we pass that to our API, and we route it somehow to our application service. And application service is just some technical infrastructure thing that whose purpose it is to load the state from some database, a relational database or some other kind of database, it doesn't matter. It loads the current state, and then it routes it to a particular aggregate. It loads the state for a particular aggregate that the command is intended for. And then what you can do, now that you have the command and you have the state, you just pass it to some domain logic. And what the domain logic can do is to update the state. So it will return, it returns the updated state to the application service. And then the application service makes sure that it's stored in the database again. So that's fine. But what about event sourcing? Well, you can make event sourcing look really similar to the previous example. The only thing that changes is that now we have an event store instead of a normal database. So again, our command comes into our API, the application service. It does the very same thing. It loads the current state from the event store. But now the current state happens to be a stream or list of events instead. But other than that, it's kind of the same. We just pass it to our domain logic. And instead of returning some updated state, it returns a list of new events. This is what we see here. And then we store it in the event store. So this is quite similar. And this is what we're going to leverage a bit later. All right. But we don't only want to write stuff to the event store. We also want to do other things like side effects and queries. So, for example, sending a welcome email to our users after they have registered. Maybe we want to block some users if they have misbehaved somehow, or create some materialized views, for example, with the 10 latest games that have been played. So for these purposes, we use subscriptions. So this is something that kicks in after the events have been stored. So just some examples. So here we have a subscription that takes the events and updates some view somewhere. So this is a materialized view that the subscription updates. And this view can be used to enable CQRS. So now if the user browses a web page or something, it will call the API, and then the API can make use of this view and return it to the user. Another thing that we can use subscriptions for, and there are many things that we can use subscriptions for. Just another thing is for integration. So here we can pass the events to the subscription, and it can create a projection to create an integration event that we then can publish to some broker. And this is one way to do integration using subscriptions as well. And as I said, yeah, there are many other things that you can use subscriptions for as well. So now that we have that out of the way, let's zoom in to look at some domain logic. And yeah, one thing to note there is the domain code that we will look at here has no dependencies at all. And this is, because I want to demonstrate that you can do this without having any, particular libraries or any particular frameworks. It's not that it's necessarily bad. I mean, if you need a library, of course, you should bring that in. But yeah, I'm doing this as a statement that you don't need to if you don't want to. The thing that you need is to follow sort of a contract. You need functions that takes a list of the existing event and then the command somehow and return a new list, a list of new events. And besides that, you can essentially write these functions in whatever shape or form you like. It doesn't even have to be functional, even though this is what we're going to explore in this talk. So we're going to look at rock, paper, scissors game, and I hope that you're familiar with this game. We're going to go beyond the very, very basics. We're going to look at a multi-round game of rock, paper, scissors that is written in Kotlin. Unfortunately, I don't have time to show you all aspects here of the game. We're just going to show some parts of it to get a feeling of how you can do it. Yeah, and yeah, another thing that I want to show here is that, yeah, you can use a mainstream language to do these kinds of things. You don't have to go esoteric and go to more, I don't know, Haskell or something. You can do this in your normal programming language for the most part. And I know this may sound, unbelievable, but it even works okay in Java nowadays, actually. So it's not really the language here that is of importance. It's mainly, the principles. So don't be too sad if you cannot read Kotlin code. It's the principles that matter. All right, so here are some events that I've made up for this game. And they are in no particular order here. But we have, for example, events like first player joined game. We have game created, game started, round ended, etc., etc. I want to emphasize here that there is a difference between the game created and game started. So in this example, the game is started when the first player shows his or her hand, but it can be created in advance. And the reason why I have made this separation is that I want to demonstrate a few points later on. So that's actually the main reason. Okay, so how can we model these events in code? Well, in Kotlin, we could do something like this. Here, I hope you can see my mouse pointer here, but it's a bit small, but maybe you can see it a little bit. So here you can see that I have something called a sealed interface. So this is essentially an interface in Kotlin, but it's sealed, meaning that it has, it provides more control over the inheritance. So all implementations are known at compile time. So if you do a switch or a when, as you call it in Kotlin, over an event, the compiler forces you to handle all cases. So that's pretty neat. Other than that, this is a normal data class in Kotlin. I think this is similar to a record in C#, something like that. It's like you create an immutable value with some stuff here. And one thing to note is that in this example, I have decided to represent the events exactly like you can see here. So I have no annotations. I have no in the JVM or in the Java space. It's very common to have some Jackson annotation that is dealing with serialization and so on, or that you need to have default constructors or other custom annotations that are framework specific. Here I'm making a point that you don't need to have that. It doesn't mean, again, that it's necessarily bad to have them. It can simplify things, but you don't have to. Okay, so what about commands? Well, in this example, we have 2 commands. Again, I've modeled them as data classes and a sealed interface. No annotations and so on the commands either. And then here we have our domain function. And here you can see, and this is the function that we will implement our logic in this function later on. And as you can see, it takes a sequence of game events, and then it takes a command. And the sequence that it takes in, you can regard this as a list if you like, but it's essentially like a lazy list. If you use Java, it's similar to a Java stream, but in Kotlin. So here it takes, essentially a list of events and then a command, and then it returns a new list of events. So yeah, here is another way of looking at it, but it's essentially this. The domain function takes the list of events, command, and returns new events. Okay, so how can we implement it? Here's one example, and this is using a bit of a functional approach. But still, I mean, if you know Kotlin, I think that this will still be recognizable to most people if you know Kotlin already. But what we do first is that for this sequence of past events that we have, we evolve them so that we get the current state. And after we have evolved, I should explain the evolve method first. So what we do here is that our evolve method, this is an extension function in Kotlin. So we create an extension function on the sequence of game events that takes the current state, but this is a default value. So in the previous example here, we didn't pass any current state to the evolve function. So then by default, it will be null. And then what we do is that we call the fold function. The fold is a really interesting function. And if you don't know fold, I really encourage you to check that out. So fold takes an initial value. Fold is a function on a list or a sequence. And it takes some initial value that in this particular example will be null, because the current state there is null. And then you pass it a function that takes, in this example, the current state and each event that is in the sequence. So what we do then is that we create this switch over the event. We check which type it has. And now this is enforced by the compiler. We need to check, or it guarantees that we have covered all the cases here. So if the game is created, we create our evolve state with the data from the event. And when the game is started, we change the state, update it, and so on and so forth for each event that we have in our event model here. Or sorry, yeah, you get what I mean, hopefully. And if, as now, the current state is null, so this is what happens. If the sequence of events are empty, then null will actually be returned here. So the input value that we pass here will be returned if there is nothing in the sequence. So now we actually now we have the current state. So now we can check on the command side. So we check which command it is. So if it's game created and we have some state, then we can throw an exception. In this example here, we throw an exception. So this is actually not a pure function. I will show you later how we can make it pure. But we throw an exception because then we know that something is wrong. We shouldn't have any past events if the game is created, or if we want to create the game. If not, then we just return a sequence of game created, which is our event for create game. for the create game command. But play is a bit more interesting. So now we assume that we must have some state here. And if we don't have some state, like if we pass play to an empty sequence of events, then it will also throw an exception that the game does not exist. But if not, we call some play method here that we will zoom into just shortly. But I will just show you here that I pass in two arguments. I pass in the command again to play, and then something that I just call accumulated changes. And we'll just see here what that actually is. And what accumulated changes is essentially a tuple that contains the current state that we saw before, the evolved state, and a list of events. And this list of events is the new events that we will return later on. So this essentially just accumulates all the events. This is why I've called it accumulated changes. But you can represent this as a tuple or pair, as it's called in Kotlin. That will work just fine as well. And then there are some utility methods here. So we can call evolve on accumulated changes. So we can pass new events. And then it makes use of the very same evolve method that we looked at before. But it also stores the changes in this tuple. It evolves the state and store the changes along the way. And then there is some, this is some operator overloading in Kotlin. So just to make it a little bit more readable, arguably. So we overload the plus operator to say that we can do accumulated changes plus some event. That just means that we evolve that event. We can also combine it with a higher order function that takes an instance of accumulated changes and return another instance of accumulated changes. Yeah. So yeah, and what you see here, oh, sorry. Yeah, let's zoom into the play method and see how that can look like. Yeah, now we've zoomed into that. So what we do here, you can see here that we get the command, and now we get the accumulated changes. The accumulated changes here will be empty. We will have no events. And we're just going to look here at the first example. So if our state of our application, if we are in the created state, if the game has just been created, what we do with the accumulated changes that we have right now, that is currently empty, we want to add, so that we want to start a new round. This is what we want to do. But start new round, if we look at the start new round, yeah, now I just zoom into the plus first. So it's this plus function that I just showed you. This is what we're going to use. But now we zoom into the start new round function. As you can see, that the start new round takes two arguments. It takes a timestamp and the accumulated changes. And that doesn't, this function doesn't work with this plus function here, because the plus function only expects a higher order function that takes accumulated changes and return some other accumulated changes. But here we take timestamp and accumulated changes. So it doesn't really match. This is why we're using partial function application here. So this means that, I think I have, this is the implementation in Kotlin. It's really quite easy, but there are a gazillion of libraries that you can use to implement this, if you don't want to implement it yourself, but it's quite easy to do. But what this does is that it takes this function, but it applies one argument. So it applies a timestamp, and then it will match our plus function that we defined in accumulated changes, and then we can pass this function to it. So what this function will do is that it will check some business rules, and then it will return new accumulated changes with the new event, the round started event here, if everything went okay. And then this will continue. We will return some more events. We will return that the game was started, and so on. So this is how I decided to implement this particular use case. And if you don't follow along, the most important thing here is that we follow this particular contract, that we get the event in, we get the command, and then we return a list of new events. And it's not really important or at least it's less important to use a functional kind of style. You could use your normal OO here as well. That would work as fine. The most important thing for this talk is that you follow this contract. So if we do things like this, if we just have functions that takes command and events and return new events, I mean, how can we test it? So testing becomes very easy when you just use functions. So here is an example where we're using standard JUnit 5 in Kotlin. So there's no framework-specific testing library or framework that we need to use. We just pass in values essentially, and there's no need for mocks. There is it will be fast and deterministic and easy to reason about as well. So I don't know if you can see my mouse pointer here. It's quite small, but yeah, we just new up our events, and we pass them along with our command to the function. We get our events back, and we can check that our expected events, that they fulfill what we expect. The same thing with exceptions. I mean, if this throws exception, we can just catch it like we normally do in our unit test. Yeah, so that's pretty nice. But there are, of course, other approaches as well. So I mentioned pure functions. So how can we refactor this code to use pure functions instead? And that's actually quite easy to do. One naive way of doing it would be to introduce something called a result, where you just you can have either error or success, and this is actually the either type. But you can model this yourself as a result if you don't want to bring in either as a dependency. So in this example, the only thing that we've changed here is that we return a result of sequence of game event instead of a sequence of game event. And if we have some error, we return the error case here of the result with the exception. And I recommend, though, that you model errors explicitly and not just as a throwable. This is just an example of how you can turn your code in a very fast manner into pure functions, if you like. And you could also return events or represent errors as events. That's also fine. But sooner rather than later, you probably want other methods here in result as well, such as map or flat map. So maybe you can bring in some dependency that has a more full-fledged either type if you're going down this route. Another example that I want to show you, this is, I actually prefer this. I usually start off with doing something like this, is to don't use any explicit command representation at all. You can just use functions. So if we just scrap the commands that I just showed you, and this is, we just have it as a function. The function here takes the events, and then it just takes the value objects. And that works as well. This is usually how I start off, at least. So instead of having two commands here, we have two different functions, create game and play hand. And other than that, it's pretty much the same. Another thing that I just want to mention briefly is the use of deciders. In Kotlin, there is, or maybe I should just say what deciders are. Deciders, it's based on the research by Jeremy Chasing, and it's implemented in Kotlin by Ivan Dugliak, and I probably butchered both of their names. But it provides some more formalized models that are an excellent match for event-sourced applications, because the examples that we've seen so far has been more ad hoc. It doesn't enforce a particular style. You can do whatever you like. This enforces some more structure, which is very good. And they have support for other things, not just aggregates. There are support for views and sagas as well. And so if you're using Kotlin and are interested in this approach, I really recommend looking into this. This is really interesting. Okay, but now we're going to look at the other side. We're going to look at Occurrent, and this is the library that I've created, and we're going to see how we can use this to store our events. And Occurrent is it's for the JVM. It's Apache 2 based. You should probably not use it in production, although we are using it in production. But if you find this interesting, please get involved or speak to me afterwards. I'd be really, really happy to talk about this, or any other things for that matter. So why did I build it? Well, I wanted to really focus on the building blocks presented earlier to make it easier to adopt event sourcing in an existing project. And this was another really important design decision, that you should be able to design your domain model without any dependencies or libraries whatsoever, and use functions or pure functions if you want. It's a library that consists of composable building blocks, so it's not an all or nothing solution. I like to be in control, so I try to keep magic to a minimum. I'd rather like to be explicit. It's also designed to be interoperable and portable, and I will explain that in the next slide. It's designed to be pragmatic. This means that you should be able to use things that you're already familiar with, such as Spring transactions if you're using a Spring application. And I wanted to use a commodity DB or database for the event store to see if that could work out. So these are some of the reasons, besides the pure interest of writing something yourself. So in Occurrent, what you do is that you typically don't store your events that are returned from the functions that we just looked at as they are, but you convert them into something called cloud events. And cloud events, it's then what's stored in Occurrent. So what are cloud events? Well, cloud events is a CNCF specification, Cloud Native Computing Foundation, for describing events in a common way. So typically they're used in a distributed system to allow for services to be loosely coupled. And they are already supported by several cloud providers that knows about cloud events natively, and I think this is pretty cool. So for example, in Google Cloud that we are using, they have special kind of functions called CloudEvent functions that can be evoked directly as a response to events from their infrastructure components, such as Google Cloud PubSub or Google Cloud Storage, which is their equivalent of S3, or Firebase events, etc. This means that you can easily pipe events, if this is something that you want to do, from the current event store to something like PubSub and gain access to a lot of functionality. So that's pretty cool. And it's used by Occurrent since it is a standard. I really wanted to, not just. I wanted to, have some form of standard where to write the events to the event store, so that it's not just an ad hoc format. I wanted to have something like cloud events. So that was actually a good fit. So what does cloud events look like? So here is an example of a cloud event. So the type here, this is this is how I typically use the cloud event. The type in the cloud event is typically just the type of the event. The source, I typically use the source of the cloud event as something similar to the category. So if you're creating this game and you have two different aggregates, for example, you may have game and player, I would represent them as different sources. And then we have a subject, and this is equal to, or I treat this like an identifier, like the aggregate ID, because this is not the same thing as the stream ID in Occurrent, because you can have multiple aggregates in the same stream if you want to. So that's one use case for using the subject property. And then we have the ID. This is the unique ID of the event. But the ID is not globally unique. The combination of ID and source must be globally unique. And then we have time that is represented in accordance with RFC 3339. And then we have the data. So now we're going to look at the event store. So Occurrent ships with a couple of different implementations for our event stores, but most of them, except the in-memory store, is based on MongoDB, because this is what we're using. But I have 3 different implementations. I have one that uses the native sync Java MongoDB driver. Then I have one implementation for Spring, that's blocking implementation. I have one Spring reactive implementation that uses Project Reactor. And then there's an in-memory implementation. I have started working on Event Store DB implementation as well. Postgres is something that I want to look into, and I would really like this to work with Google Cloud Spanner. That would be awesome if that would be possible. So yeah, I will try to see what I can do in the future. So how do you create an instance of this event store? Well, this is not so strange. You create some configuration. You define where you want to store your events, which collection you want them to be stored to. You instantiate some transaction manager, and then you just new up the Spring Mongo event store. And this is the blocking implementation. And so how do you write events to the event store? Well, then you create a cloud event. So here's an example how we can create a cloud event. And this is using the standard Java Cloud Event SDK. So it's not something that I've made. I'm just using the SDK. Then we write it to the event store, and we can read events from the event store like this. We get an event stream back that contains the version number and some other things. Kind of what you would expect, I hope. But a cool thing now is that if we look under the covers, how will this actually be stored in MongoDB? And this is how events will be stored in MongoDB. And as you can hopefully see, is that it is very similar to the cloud event that I just showed you. Actually, this is in accordance with the cloud event specification. So this is actually a cloud event, even at the data store level, which is pretty cool. So you know not only what your events look like in your code, you also have a sense of what it will look like in the actual database, which for me at least gives peace of mind. I know how it will be represented. And you can see here that Occurrent will add 2 so-called extensions to the cloud events that you pass into the event store. We will add the stream ID, and we will add the stream version. Okay, so that was the event store. Now we're going to look at the application service. And this is, again, this is not something that you need to use if you don't want to. You can write your own. It's actually pretty easy to do. But Occurrent ships with a so-called generic application service that you can probably use for most cases. So we're going to look at the one that is shipped with Occurrent. So it's essentially an interface that looks something like this. So it has one method called execute that takes the stream ID, and then it takes a function. It takes a function that takes a sequence of the type of your events and return another sequence with the type of your events. So this is a higher order function. So that requires you, your function needs to take the current events of the stream, and then what you should return are the new events. So here is an example of how you can use it. So here again, just as a reminder, here we have our domain function that takes the events and a command. Then we configure our application somehow. We instantiate this generic application service with our game event type, because this was our type of our events. We pass in the event store that we've also created up here, and something called a cloud event converter. I will explain that in a second. And then we say that we have a REST API. So yeah, here in some way we get the game ID, we get the ID of the one who wants to create the game, the max number of rounds, and then we instantiate our command, and then we call the application service. So we call it with the game ID. This will be the stream, and here you can see that we implement our higher order function. So this events here, these are our current events that we just pass to the handle function here with our command, and that's it. Now we have loaded the current events, and we have saved the new events. What we also can do here is to make use of partial function application again, if we don't want to write this higher order function explicitly. So we can just call partial, and partial here is shipped. This is shipped with the application service in Occurrent, so you don't have to write it yourself. You can do partial function application, so you just call handle, which is our domain function. You call that with the command, and then it will work as well. But this also works for, if you remember, the other kind of implementation that I showed you. If we don't have any commands, we just have functions. So it works the same way. So instead of generating a command down here, we simply call our function. So we take our current events, and we just call the create game function in this case with all of the arguments. And this works in a similar manner. Similarly, we can use a partial function and just pass in our ID, timestamp, creator, etc. Directly here, and we don't need a higher order function. So it works the same way, even if you have commands or don't have commands. You use the same partial function, that is partial function that is shipped with Occurrent. And another cool thing is that we can also compose commands. And this is why I separated the create game and start game. Because imagine that perhaps in the UI, we want to both create and play the game when the user chooses the shape of the hand. So we can do that without changing our domain model. What we can do is that we can compose the two functions that we have. So we can compose create game and play hand using this compose commands function that is also shipped with Occurrent. And this is nothing fancy. This is actually just a variant of normal function composition. So there is no there's no infrastructure thing that I need to do here. This is just some variant of function composition, and I think that is really cool. And this will now be an atomic operation since it is on the same stream. Either all events will be persisted, or no events will be persisted. So that is, I think this is pretty cool. You can do a lot of things with just functions. So let's look at how you can actually implement this application service itself. The actual implementation is a little bit more complex, but not much. I mean, as you can see, it's just a couple of lines of code. So what we do is that we read the events. These are cloud events that we read from the event store. We transform them using this CloudEvent converter that I will talk about very soon into a sequence of your domain event type. Then we just call this higher order function, and then we write the results back. And this will use optimistic concurrency control. So if two processes try to write at the same time, we will get an exception. Okay, so let's look at the CloudEvent converter part. So the CloudEvent converter is just an interface that essentially you have to implement two functions, two CloudEvents and two domain events. And there are a couple of built-in implementations that you can use that works off the shelf, like Jackson Xstream, but then there's a generic thing that takes some higher order function. But in production, I would recommend to create a custom CloudEvent converter, so you are in full control of how your cloud events are constructed and how you convert between cloud events and your events. So here is an example. What I do here is in the two cloud events example here. I convert the data. I convert that into a map, a hash map, and then I just construct the cloud event using the normal cloud event SDK and pass the data here to the cloud event. And if I want to go the other way around, I check the type of the cloud event, and I use the type to determine which domain event I want to instantiate from the data represented in the cloud event. So this is typically how I do things since I like to be in control, but you can decide to use one of the shipped or ready-made libraries as well for CloudEvent conversion that I've made. All right, so let's move on to subscriptions. So in Occurrent, I have implemented subscriptions using something called subscription models. So what you do is that you instantiate something called a subscription model, and there are different kinds of subscription models, and then you call subscribe to create an actual subscription using this subscription model. And the cool thing is that different subscription models can be composed with each other. To gain more functionality. And another thing to note is that you can use reactive event store and blocking subscription models if you like, and vice versa. So it works both ways. And yeah, they're also distributed if the event store allows it. So here's an example on how you can use it. So you create a subscription model, and then you call subscribe with the ID of the subscription, and then the blocking subscriptions are callback based. If you use a reactive subscription, then it will return a Flux instance, which is better if you want to work with streams. And yeah, you can decide to subscribe in the past as well, but by default, you start at the current time. And you can use filters. You can specify the different properties of the CloudEvent. So you can say that I want the type to be equal to game ended. And you can compose. So you can say that, for example, I want a filter with subject with a particular ID and type game event. And these filters will be applied at data store level, so they will be really fast. And here's an example of composition. So in this example, we compose a subscription that is not durable. And I'm sorry, I will go over time here a little bit since I lost a couple of minutes in the start of my talk, and I hope that's fine with everyone. Otherwise, it's okay if you leave. But yeah, here I have a subscription model that is not durable. So if I restart my application, I will lose my where I am in the subscription as a consumer. If I don't want to do that, I still create this subscription model. I create some storage. This is some checkpointing storage. I call it subscription position storage for some reason. And then you compose this non-durable subscription model into the durable subscription model, and this will actually give you a new subscription model that is now durable. And you can compose that further to support catch-up subscriptions and other things. So just to summarize subscriptions, we have reactive and blocking implementations. There are checkpoint storages or subscription position storage, as they're called in Occurrent for MongoDB and Redis. You can also really control how often you should checkpoint. You're in control of that. And there are other kinds of subscription models as well. So catch-up and competing consumer subscription model. And some other features that I just want to mention, and these are a bit contested features of whether you should use them or not. I have this scary emoji here because you can actually query the event store, and I kind of like this personally, but I know that many people don't like it, and it's not something that you have to use, obviously. But since, I know here that this is MongoDB that we're using under the covers. MongoDB has good querying support. If I don't have a gazillion number of events in the event store and I create the right indexes, these queries are actually really fast. So here's just an example of how it can look like. So here you can query for a particular subject, and so what has happened in the last 2 hours, and I sort them by descending order. And this is actually the very same query API that you saw in the filter example just previously. It's the very same thing. And this works now because we know how the events look even in the database, right? We know that they are represented as cloud events. This is why this can actually work. And yeah, here's just an example of how you can get to the alt stream as well. But you can do other, even more crazy things. Again, this is not something that you would do very often, if at all. But you can actually delete. You can delete event streams. You can delete a particular event. It works. Or you can delete using this API here as well. And I think this is pretty useful if you implement something like closing the books and you want to remove old events that you don't want to have anymore for this stream. Then you can use something like this. Oh yeah, here is another thing that you can do. You can actually update an event. Oh my God. This works. So you can do that as well. And it can be useful, I think, if you, I know, of course, you can do other things that are probably better than this to solve your GDPR issues, but you can also update the event and remove the actual data if you want to. And we're getting close to the end here, but just bear with me a couple of more slides. So you can also use indexes in MongoDB to create something like unique indexes, which can be quite useful. So, for example, if I have a constraint that a particular type of event should, or like if a person can only have one email address or something, then you can enforce that by indexes if you want to, and you can enforce, some constraint. For example, if you have a use case where a manager can only administer one particular account or something at a time, you can enforce that by using transactions. And using transactions, you can also get consistent read models. And I think this actually works pretty well in my experience. And the last thing that I want to show that I find pretty good is that, well, I'm quite interested in testing. I've written some open source testing frameworks in the Java community before. So of course I want a good test story, and I think it's pretty good here in Occurrent. So what you can do with a subscription model in particular is that you can start and pause and resume individual subscription models so selectively. So, for example, in your integration test, you can pause all other subscriptions to the one that you really want to test, and so that other subscriptions don't interfere with your test, etc. And that's pretty nice. Okay, so if you want to know more about Occurrent, or if you want to, you should visit the website. Feel free to reach out to me if you want to discuss this more, or if you have any feedback or comments, or if you'd like to get involved, that would be awesome. Thanks a lot for the talk and for sticking around. Thanks.